Okay, so now we've established what the chain rule is. The chain rule says that if y is some function of u, that the derivative of y with respect to x, oh, by the way, and u is some function of x, is the derivative of y with respect to u times the derivative of u with respect to x. And we can extend this to a whole bunch of different functions. So for example, the power function or the power rule. Y equals some function to the n where that function is a separate function of x. We know that the derivative of y with respect to u is n times u to the n minus 1. And to take the derivative of y with respect to x, we're just going to take n times u to the n minus 1 and then multiply it by the derivative of u. Pretty straightforward. This is going to be true of any composite function. So let's do some quick examples. Example number 7. We want the slope of the tangent to the curve y equals sine to the 5th power of x at x equals pi over 3. So remember that this is how we write sine of x raised to the 5th power. Those are the same thing. And so the derivative of y with respect to x, well, we're going to take the derivative of the power, 5 sine to the 4th of x times the derivative of sine, which is cosine, and then at pi over 3. So the derivative of y with respect to x, and one notation that we may not have seen before is I might draw that little line and say at x equals pi over 3. So it's going to be 5 sine to the 4th power pi over 3 cosine of pi over 3. And hopefully you have at this point completely memorized the unit circle. Pi over 3 is right up here. And we know that this is 1/2 comma root 3 over 2, where of course the height is the sine value and the base is the cosine value, since it's a unit circle. And so we know that this is equal to 5 times, well, the sine value is root 3 over 2 to the 4th, and the cosine value is 1/2. And you could do this in your calculator, but the nice thing about this is actually pretty straightforward and simple. Root 3 to the 4th power is root 3 squared squared, so that's 9. So we get 5 times 9 on top. And we've got 2 to the 4th, which is 2, 4, 8, 16 times 2, which is 32 on the bottom. And there is the slope of that tangent to the curve. Let's see. Let's do a similar example. Show that the slope of every tangent to the curve. I don't know why I said a similar example, because it's just another example. In the book, it's 7b, which sort of makes, little to no sense, but whatever, is positive. And so we don't actually care about the values. What we need to do is show that this is positive. So I could use quotient rule. I do have a quotient here, but the problem is with u equal to 1. So for quotient rule, u is equal to 1, the derivative of u is equal to 0. So you could do the whole quotient rule process, and you're just going to end up with a bunch of complicated stuff that some of it disappears. It's a lot easier to just write this as 1 minus 2x to the negative 3. And now we've got a power and we've got an inner function. So the derivative of y with respect to x is equal to negative 3 to the -4, remember we're subtracting 1 from the negative, times the derivative of the inside, which is -2. And so doing a little simplification, I get 6 over 1 minus 2x to the 4th power. Well, this is positive, and this is positive, which means that the answer is always well, not equal. It's always positive. Has to be a positive divided by a positive. So go ahead and do exercise 53. Again, if you look in the description of the video, you'll see what book we're working with. And if you want to follow along with the exercises, or if you're using the same book, you're certainly more than welcome to. All right, so we'll be back with a quick video on what do I do if my trig functions are in degrees instead of radians, because we've been assuming radians all this time. Generally in math, we assume radians unless told otherwise. And so we'll be back in the next video. Thanks for watching.